Hello students, welcome to EPG Pathshala. I am Dr. Rashida Kanchwala, Professor, Government PG College, Mahu, Indore. Today I am going to talk about pasteurization of milk from your paper of food science. After going through this module, you will understand various objectives of pasteurization, difference between different techniques of milk preservation, identify the difference between different heat treatment technologies of milk, and very important, you will apply this knowledge while selecting milk. Students, as of us know that milk is a food with ample nutrients, and as it is a good food for us, similarly, it is an excellent medium for microbial growth. Storage of milk at room temperature causes various bacteria and pathogens to proliferate. US Center for Disease Control says improperly handled raw milk is responsible for nearly 3 times more hospitalization than any other foodborne disease outbreak. From this statement, we can say that milk is one of the most dangerous food in world. Therefore, milk is pasteurized. Pasteurization of milk extends its shelf life by killing microorganisms and inactivating the enzymes present in it. There are two main kinds of heat processings which are applied on the milk. First one is pasteurization. Pasteurization generally extends shelf life of a milk by a little extent because it kills most food spoilage organisms and pathogens, that is disease causing organisms. Second type of heat treatment is sterilization. This is a more severe process which destroys all microorganisms in the milk, although it may, however, change the organoleptic qualities of the product. Students, as you have come across the benefits of pasteurization, let we know about types of thermal processing of milk. As you know that thermal processing techniques employ heat as the main energy source to change the conditions in milk and to extend its shelf life. The chief thermal processing techniques are thermization, pasteurization, sterilization, ultra-heat treatment, and irradiation. Let us now understand these techniques one by one. Let us understand these techniques one by one. First technique of heat treatment is thermization. Students, it is not possible to pasteurize all milk immediately after it has been received from dairies, because it requires some time in communication. Under such circumstances, some of the milk must be stored in such a condition that it can persist for some hours or days without heat treatment. Hence, it becomes necessary to preserve the milk without deterioration in its quality. At this time, thermization of milk is done. Thermization is actually a sub-pasteurization process which temporarily inhibits bacterial growth in the milk. It is a process of heat treatment in which temperature and time combination is definitely less than pasteurization process. In thermization process, the milk is heated to 63 to 65 degrees centigrades for about 15 seconds. It aims only to prevent aerobic spore forming bacteria from multiplying. After thermization, the milk is rapidly chilled to 4 degrees centigrade or below. Students, after going through the process of thermization, let we know what the advantages thermization incurs. Thermization does not adversely modify the sensory characteristics of milk. It has no effect on appearance, taste, and nutritive value of the milk. Proteins in milk are not denatured by this process. Therefore, it is a good process for cheese making. It does not affect the taste of milk, and it destroys pathogens and sometimes spoils, causing microorganization. Now we come to second type of heat processing, that is pasteurization. In pasteurization process, usually milk is heated to a specific temperature for a predefined time, followed by its immediate cooling. The time and temperature of pasteurization differs according to the product being pasteurized. Variation in time and temperature of pasteurization minimizes chemical, physical, and organoleptic changes of the product. Before commencing to pasteurization, let we have an insight of pasteurization. Students, pasteurization is a heat treatment of food preservation method. It kills a part of the microorganism present in the food. Therefore, this technique is used for foods that can be stored and further handled under suppressed microbial growth condition. It is very important to note that pasteurization does not destroy all the bacteria. So, for consuming milk in long runs, it must be preserved in a manner which suppresses its microbial growth. Second thing with pasteurization, it, it does not destroy heat resistant spores entirely because the temperatures which are employed for pasteurization are not high enough to destroy spores. Therefore, if pasteurized products are not given a safe, shelf stable storage condition and proper low temperature, it can cause diseases due to germination of these spores. Third thing about pasteurization is that pasteurization depends upon the heat resistance of a particular microorganism. In conjunction with this, heat sensitivity of the product is also to be taken in consideration. For the products which are heat sensitive, high temperature pasteurization cannot be done even if heat resistant microorganism is there in it. Although besides these concerns, pasteurization has some advantages. Due to low heat treatment process, the nature of food does not change. That is, it preserves the nutritive value of food. Before proceeding to methods of pasteurization, let we learn about parameters through which we can decide whether milk is safe for drinking or not. Students, direct microbial techniques are the ultimate measure for detection of pathogen contamination. But as we know that these methods are costly as well as time consuming. They requires nearly 24 to 48 hours to produce results. Therefore, we require some other method because at such a long time, the pasteurized milk will get destroyed. Therefore, a test of activity of alkaline phosphatase is applied on the milk to detect whether it is pasteurized or no. The alkaline phosphatase is the enzyme which is highest heat resistant and the time and temperature ranges which denatures alkaline phosphatase are similar to the ones required to kill B. tuberculosis, that is the bacterium which is pathogen and which requires highest time temperature combinations to be killed. Different nations has posed different food safety standards. In India, FSSAI has posed pasteurization standards. According to it, pasteurization or pasteurized are similar terms that shall be taken to refer to the process of heating every particle of milk of different classes at least 63 degrees centigrades and holding at such temperatures continuously for at least 30 minutes or heating it to at least 1.5 degrees centigrade and holding at such temperature continuously for at least 15 seconds or an approved time temperature combination that will serve to give a negative phosphatase test. Students, before going to different methods of pasteurization, let we first know how the heat is applied to the product which is to be pasteurized. Chief agents by which heat is applied to pasteurized products is either by direct heating or by application of steam or by irradiation. Students, selection of different heating methods depends upon the product which is to be pasteurized and time temperature combination which is to be applied. Main variables which govern the selection of heating technique are type of food, viscosity of the product, pH of the product, particle size in the product, type of equipment to be used and method to be used. Now, we will learn about agents of pasteurization in detail. Pasteurization by heating involves a high temperature, short time treatment in which pourable products such as juices are heated for 3 to 15 seconds to a temperature that destroys harmful microorganisms. After heating, the product is cooled and packaged. Most drinks, boxes and pouches use this pasteurization method as it allows extended unrefrigerated storage while producing a safe product. It is a better method for preserving color and taste in some products. The second agent for heat application is steam. As we know, steam is formed by superheated water which has a temperature higher than boiling temperature of water. This technology is used to control or reduce harmful microorganisms in some foods like beef. This method is not applicable to milk. The last agent of pasteurization is irradiation. In irradiation, foods such as poultry, red meat, spices, fruits and vegetables are subjected to small amounts of gamma rays. This method is rarely used for milk. Therefore, we are not discussing it in detail. Now, we are well accustomed with the different agents of heating. Let we know what are different methods of pasteurization. Pasteurization can be broadly classified into 4 methods. High temperature, short time treatment, it is generally referred to as HTST. Low temperature, long time pasteurization, it is referred to LTLT. Sterilization and ultra heat treatment. Now let us come to these methods one by one. The first and most important method of pasteurization with respect to milk is HTST, that is high temperature short time sterilization method. This method works on the principle of conduction of heat. In this method, a plate heat exchanger is employed. Plate heat exchanger is basically a series of stainless steel plates stacked together with some space in between. The spacing forms chambers to hold the milk as it passes through. There are two types of chambers, even and odd numbered chambers. We can say that chamber A and chamber B. In the regenerating section, cold milk is pumped through the chamber A, while milk that has already been heated and pasteurized is pumped through the chamber B. The heat from the hot milk passes to the cold milk through convection and conduction of heat through steel plates. The cold milk is warmed through the warmth transfer of hot milk. We can see from the accompanying diagram of the heat exchanger, plate heat exchanger. Here we can see three chambers. First is regenerator chamber, second is heater chamber, and third one is cooler chamber. Generally, the milk which is to be pasteurized is induced in regenerator chamber, which goes to heater chamber. It again comes to regenerator chamber and then goes to cooler chamber. In heater chamber, the milk is heated for up to 72 degree centigrade, which is the goal temperature of high temperature short time pasteurization method. It is passed to a holding tube. It takes the milk about 15 seconds to pass through the tube. These 15 seconds are actually the time requirement for the method of pasteurization. We can say that within these 15 seconds, milk is officially pasteurized when it passes through the holding tube. From holding tube, it goes to regenerating section. In regenerating section, there are other pipes attached side by side which are holding cold milk. The heat by conduction heats the cold milk to up to 32 degree centigrades. The regenerated milk is now passed to cooler section where milk is cooled to 4 degrees centigrade immediately, and the new upcoming milk from regenerator section or upcoming section now goes to heater section, then regenerating section, and then cooler section. Thus the cycle is maintained. It is known as continuous pasteurization process. The second method of pasteurization is low temperature long time pasteurization method, that is LTLT. In this method, milk that is used for ice cream making is pasteurized by this method because HTST affects some of the qualities of milk adversely in contrast with ice cream making. Therefore, this process is employed to pasteurize milk which is used for either ice cream making or for cheese making. This process is generally a batch process in which milk is kept into a wet pasteurization pasteurizer, which consists of a vat surrounded by either circulating water, steam, or heating coils, which heats it to 145 Fahrenheit. This temperature is maintained for 30 minutes. After 30 minutes, the milk is removed from vat and it is cooled. Students, after getting through pasteurization, let we come to second technique of heat treatment of milk, that is sterilization. Sterilization uses temperature in excess of 100 degrees centigrade. These temperatures destroys nearly all microorganisms present in a food. Sterilization also destroys organisms which can form spores and have the ability to survive at high temperature. Some organisms can, however, survive the sterilization process if it is not processed for enough time or a high enough temperature. Example of surviving organism is Clostridium botulinum, which is a cause of lethal botulinum poisoning. Sterilization process can be divided into two main categories. That is, first is in container sterilization, which is used for foods which are placed in containers such as cans, bottles, and plastic pouches. Second method is continuous flow system like HTST. In this method, ultra heat treatment processes, which generally involves heating to 140 degrees centigrade to 150 degrees centigrade for 1 to 3 seconds are kept, which is the fourth type of pasteurization we have quoted earlier. There are two types of continuous flow sterilization techniques. These are steam injection and steam infusion technique. In steam injection technique, the steam is injected along with the product in a vacuum, and the injected steam is separated when the product is cooled. This technique is generally employed for milk and pourable products. Whereas in steam infusion technique, the steam is infused within the product. This technique is employed for solid products and it is not applicable for milk. Along with the type of product, the choice of system depends on viscosity and susceptibility of pouring of the product. After going through different sterilization technique, now we come to merits and demerits of sterilization. Sterilized products have a long shelf life than pasteurized product. But the properties of sterilized products changes, which the pasteurization process doesn't do. Sterilization process can only be applied for certain foods which are not very heat resistant. It also destroys nutrients of food, although it extends its shelf life. The taste of sterilized milk is peculiar and it resembles that of boiled milk, which is not very much liked by everyone. Now we come to the changes which sterilization incurs in food. The first and foremost change is amylolytic ferment of the food is destroyed. That is, there is no further microorganism to cause deterioration of milk. As a result, the milk is safe to be consumed for a long time. The second change is the casein of milk coagulates less readily by renin, which is a concern for making fermented milk products. Therefore, sterilization is not employed for the products like yogurt making, cream fetch making, cheese making, and ice cream making. Besides this, the sterilized milk is also hard to digest because the digestibility of casein by gastric and pancreatic juice is somewhat retarded. Side by side, fat is less promptly absorbed than which is normally absorbed by the intestine. Some of the milk sugar are also destroyed. Therefore, pasteurization technique should be employed with great caution. If sterilization is required, then only it should be done. Otherwise, sterilization is detrimental to the product. Last heat treatment technique is ultra heat treatment, in which milk is heated to 140 degrees centigrade for 4 seconds. This process is achieved by spraying the milk through a nozzle into a chamber that is filled with high temperature steam under pressure. After the temperature reaches 146 degrees centigrade, the fluid is cooled instantly in a vacuum chamber and packed in pre-sterilized airtight container. Ultra heat treatment process results in better outcomes than sterilization process or pasteurization process. It gives increased retention of nutrients because exposure is for a very short time. There is no enzymatic browning of the product, which results in retention of color and flavor of the product. The proteins are also not denatured, therefore, texture of the product is also maintained. The high temperature Heating extends the refrigerated shelf life of milk from 60 to 90 days. Students, after going through this module, you have very well known that milk is a perishable food which can be destroyed by enzymes of microorganisms, or it can cause disease due to growth of pathogens. So, it is necessary to make it safe before consuming, and there are many methods of making it safe. These methods increase keeping quality of milk and decrease its pathogenic qualities. Heating of milk to various temperature time combinations fosters these purposes partially or wholly. At low time temperature combination, pathogen activities are subdued without affecting sensory and nutritive qualities of milk, but at high temperature time combinations, pathogen activities are almost destroyed. Keeping quality of milk is increased, but its sensory and nutritive qualities are decreased. So, before purchasing milk, we have to wisely decide what decision is to be made, whether we require a higher keeping quality or we require a higher nutritive value. Thank you.